hurled into the air. The entire Japanese archipelago is disintegrated, as is some of the Asian continent. The shattered remains are hurled out into space way beyond the atmosphere to bombard the Earth with deadly intent when they re-enter. At 7,000 meters, 23,000 feet, the rim of the crater is higher than many mountains on Earth today. The size of the crater would be a distance of 2,500 miles or 4,000 kilometers. And this is just the start. NASA has the world's largest collision test machine used to try and find out what would happen after the moment of impact.
Okay.
Dr. Peter Schultz fills a small tank with water to see how the ocean would react. The actual impact object is tiny, but it will hit the water at a speed 20 times faster than a bullet fired from a pistol.
Oh, gorgeous! Joe, that is gorgeous.
Just one tiny aluminium bullet had this result. But the impact which created mayhem is not the entire story. To get the full picture, the moment of impact has been slowed down so that 1 second seems to last an eternity. At the moment of impact, it is like slamming the brakes on. The kinetic energy of the bullet is transformed into heat. White smoke rises. It may look like a splash, but it is actually water vapor. The heat vaporizes the water in an instant. And heat has a deadly potential.
When an asteroid hits the surface of the Earth, the material is heated up to temperatures that get up to the point of, say, 4,000 to 6,000 degrees centigrade. This is as hot as the surface of the Sun.
An experiment was carried out at Hokkaido University in northern Japan to try and discover what could happen to the rock bed at the point of impact. A tiny rock was put into a special oven that could cook the sample to a temperature of over 2,000 Celsius, 3,600 Fahrenheit. As the temperature rose higher, the rock began to melt and boil like water. The gas produced is called rock vapor.
The rock vapor, when we generate this rock vapor, it will expand extremely fast. It expands so quickly that it can cover eventually the entire planet. When an impact hits, it's not just the crater that forms, it's not just the area where the impact occurred. It's all the heating that's created in the atmosphere and around it. So heat really is the killer.
Moments after the impact, rock vapor, the temperature of the sun, begins to engulf the world. Could any life at all survive this impact? Immediately after the impact, the rock vapor rises up from the crater in a dome, then spreads out in all directions across the globe. 3 hours after the impact south of Japan, the expanding wall of vaporized rock reaches the mountains of the Himalayas. The perpetual snows are instantly evaporated. Soon the wall of fire reaches the Amazon, the furthest distance from the point of impact. The forest spontaneously combusts even before the rock vapor arrives. Just 1 day after the impact, the entire planet is covered. Every living plant or creature is vaporized. It's been estimated that this vapor would cover the entire globe for almost a year. It would be as if the sun had come to Earth. The ocean would start to bubble and boil. And as the water evaporates, the oceans would drop at the rate of 5 centimeters or 2 inches every second. Even the salt deposited on the ocean floor vaporizes, and then the very bottom of the sea melts. Nothing is left untouched. One month after the impact, the surface of the world has been sterilized. The oceans have vanished. All that remains is the superheated bedrock. It is thought that an impact like this happened 6 times in the violent past of the Earth's history. If there was life, it was assumed that it too would have been wiped out, only to begin again. But now science is not so certain. Now there is the strong likelihood that life, despite the odds, has survived. But how could that be possible? With the oceans gone, where could life have found a sanctuary from the searing heat? A clue to the answer was found in salt. These salt lakes